Hello, this is Jeremy Comel, Research Associate Faculty at Yale University and CEO of Innovative Omics, and today we're going to be discussing how to rename your files for the correct conventions for LipidMatch, FluoroMatch, PolyMatch, etc., all of our software platforms. So as we discussed in the prior tutorial how to acquire your data, we recommended you acquire data-dependent analysis, especially iterative exclusion or intelligent acquisition. So if you're unfamiliar with those terms, you can look back to that tutorial video. You can also get targeted MSMS data. All of this data, which will be used to identify your compounds, the naming convention is DDMS2. I like to put underscores around it, but just DDMS2. And then, as with all the files, no matter what type, you want to put underscore neg or underscore pos to do the polarity. So that's underscore NEG. And all of this, of course, is in the manual, these naming conventions. And so for full scan data, you'll want to either have target underscore neg, for example, or not have target. The difference is that the targets are used as reference samples. So they're used to generate EICs, MS1s that are all visualized in the FluoroMatch visualizer. For those that don't have target in their name, you won't be able to visualize the MS1 spectra and the EICs for those compounds when going through the visualizer. Obviously, you can manually look through them through vendor software or MCMI. Either way, both targets and ones without target in the name but still have underscore neg will be used to get integrations, peak areas, peak heights across all of the samples that either have target or don't have target in their name. So you don't need two of these. So if you have a target, you don't need a version that doesn't have target in the name. So these are your full scan files. Let's say you do polarity switching. You still have to split your files either during the conversion step when you convert to MZML, or if you're loading the raw files into the software, which you can use .d, .raw, etc. Then you have to use some kind of preprocessor to split the polarity switching. Similarly, with the MSMS data, let's say the MSMS data you use data-dependent analysis, you're also using for your full scan data. You have to copy and make two versions of this file, which we'll show later, and then one will be for your MSMS and one will be for your full scan. The only last two types of data types, so one is your blank, and that just needs blank anywhere in the file name, and then of course underscore neg and underscore pos. For both DDMS2 blank and the term all ions, which is used for all ions approaches, as well as Q-ray, you put all ions in the name here. Those names can be anywhere in the file, but for the underscore pos and underscore neg, that has to be the end of the file right before the file extension. So I recommend that when you're acquiring the data that you use these naming conventions and then you never have to rename your files. I'll delete this. So what if we didn't have the correct naming convention? So one we can manually go through here. All right, and let's make this even less of the correct naming convention. Let's take out the underscore neg. So let's say B1 through 3 is our blanks, and that's how we name them. And this C both has MSMS data and full scan data, and we want to use it for both. So first, what we can do is we can open the renaming tool. So if you go to your software, FluoroMatch, LipidMatch, PolyMatch, and you go into the renaming tool, and you go and click the exe, it will open up the renaming tool. Note here we'll have to change our display options. I had it zoomed in just so that you could see better. Rename button. So first, we're going to retain the original file name. You don't want very large file names for the original file names. That can cause problems in Windows. And similarly, you don't want very large project names. So just a few characters here. We're going to choose negative polarity in this case. We're going to browse for our output directory. Usually I just keep that as the same as the input directory. Okay, so there's our output directory. And then literally all we have to do is drag our files in. So if we go to the not renamed files, we can take all of our blanks, and we want to make sure we go to the blank tab over here, drag the blanks in. For the DDMS2, we're going to drag this NSC in, but it's also going to be our full scan data, so we're going to drag it there as well. And we're going to click the rename, and we're going to rename these files. And so here they are, renamed, and it generates a copy of them, right? So here's the same copy of those files. Note that it created two, a target and a DDMS from that NSC. And then you also have this list. So let's say you didn't retain the original file name. There's a trace back, so you always know what the original was and what the new one is. So we can close that. Now, that's pretty much it for the naming conventions. I do want to note that the all ions don't use this because this used old naming conventions. So you want to manually type in all ions and generate those files. Right. So again, this could be any vendor. We're just using Agilent as an example. You can drag the vendor files directly. It depends on the vendor, and if you look for the tutorial documentation, right? So if you go to the website and you go to innovative-omics.com and you scroll down to any of the software, one, you can see the video tutorials such as these, but also you can see the manual troubleshooting, and you can even edit and add feedback for me. That would be great. And you can find for each vendor what's the expected workflow for that vendor. But briefly, for Shimadzu and Agilent, you want to use the vendor software to convert to MZML before you use FluoroMatch. For Thermo and a lot of other instruments, you can just drag the vendor files onto the software platform itself. For Waters, Bruckers, I would recommend converting to MZML first based on their optimized parameters. So for Agilent, we're going to use their own software. So I'll show you an example. So you'd open up Qual, you'd load your data in. So I loaded these data files in. And then all you have to do is go into your method editor, click MZML, and click export. So quite easy. If you don't see the method editor, you go method editor over here. Show you the method editor, click MZML, and click export, and it will generate MZML files that you can drag directly into the software. For non-Shimadzu and Agilent or any vendor that doesn't have their own open source export option, then what I recommend is that you use MS Convert, right? So you can open up MS Convert. You can download it at Prodeo Wizard. Use the latest MS Convert version. Or if you go into our software and you go into Flow, MS Convert is over here, and you can find the software GUI over here that we know has worked with the rest of our workflow. There it is, MS Convert GUI.exe. Once you load it in, you can save presets so that you don't have to do them again. But I often do peak picking, and again, this is in the written manual as well. Add, so let's say you wanted level 1 and 2 after you loaded your files in, so you browse, load them, and click add. They'd be in here. Then you would also potentially want to do a subset, so MS level 1, 2 is fine. Maybe number of data points. If there's only one data point in a scan, that's probably noise, so I put 2 or more. Seconds, so if you want to take out your void volume, you can go 60, which would be a minute. Let's say that everything below a minute, you know that that's garbage and you don't want to look at it. To 360, let's say your end of your analytical run is in 6 minutes. So you can do that. So you would add that. And then there's one other threshold I often use, which is the intensity. So for thermo, for the Q exactive, it could be 1,000. So you could add that in here. Really drag that up. Order does affect the way this processes. And so I usually keep the MS level at the end. And peak picking always is first as far as your parameters. So then you could save these. Some people like 64-bit, 32-bit, depends on the vendor. 32-bit is just going to be a smaller file, which is helpful. This will store a little more in the decimal places, etc. So, and you can use zlib compression in most cases. Again, depends on the vendor. Look at the manual for some exact parameters, and then you can select MZML, click Start. You may want to do a couple in parallel to make it go faster, assuming you have multiple cores or threads. So that is the MS Convert workflow. We've also covered the qual workflow. And then once you get those MZML files, you can drag them directly into the software, which we'll show in the next tutorial video. So thank you for joining us.